Okay, we're starting the second half of chapter 4. We're at the beginning of the notes. We're just going to do page 1 in this video. And I've already written some of these out for us. So the beginning, it says we're going to talk about congruent figures. We've already talked about the word congruent. It means something is the same size and the same shape. Put a bubble around that. So that is not anything new. Okay, so now when we're going to talk about congruent figures, it's no longer just congruent line segments or angles. These could be any polygon. So the first way we're going to define this is that you need to be able to use one of the rigid motions, so a translation, a reflection, or a rotation, to map one figure onto the other. And remember, rigid motion, another word for rigid motion is isometry. Write that in. It just means that you move the shape around the coordinate plane or whatever plane you're using, and its shape and size does not change. So two shapes that are congruent could look like, if I have a trapezoid looking thing here, and I just translate it over to here, I didn't change, well, it's not supposed to change, the size or shape of that trapezoid. It just shifted over here. So these two figures are congruent. You could also take your trapezoid and reflect it. That's another example. And it's still congruent. So these two are congruent. These two would also be congruent by the transitive property. Okay, so not congruent is if I have a triangle and I zoom in and make it bigger. The shape is still the same. It looks like it's an equilateral triangle, but the size changed. Okay, so it got a lot bigger. So it's the same shape, but not the same size. Another option is if I take this bigger triangle and if I make it into an obtuse triangle, these might be the same size. They might have the same perimeter or the same area, but that does not make them congruent because now they're different shapes. Okay. So on this one here, we're supposed to look at a graph over here and identify any of the shapes that are congruent. So I'm going to start with this rectangle and this rectangle. These rectangles are the same size and the same shape, and we need to figure out why they're congruent. So I'm going to put that the first rectangle is GHIJ is congruent to the second rectangle, which is NPQR. Notice I named those, put the corresponding points together in the same order. And the reason those are congruent, if I look, the easiest way to describe the motion from one to the other is that you just translated one to the other. So I'm going to say it's a translation. And the rule would be every point is shifted down 6. So you write that as y minus 6. Okay, so the next one that's congruent, I'm going to use triangle KLM. It looks like it's congruent to this one over here. KLM would go with STU. And those two are congruent by a reflection. It looks like it reflected over the y-axis. So to write it out, write triangle KLM is congruent to triangle STU, and the reason is a reflection over the y-axis. Okay, so then the last one, these two look like they're congruent, and just looking at it, it kind of changed its, it turned, so I'm thinking it has to be a rotation, and it looks like ABC would go counterclockwise to here, and if I go counterclockwise, that's a positive angle, so we're going to use triangle ABC is congruent. We have to figure out which point corresponds with A. A would correspond with D in the picture, and B would rotate over here to E, and then C would go to F. So this is a rotation. And this one is rotating by 90 degrees because it just moved from one quadrant to the next. That's the easy way to tell that it's just 90 degrees. Okay, so those are all the congruent figures in that picture. So the next definition we have is a congruence transformation, and that's just a fancy way of saying a rigid motion or a composition of rigid motions or isometries. We usually call it a congruence transformation when we're using transformations to determine if two figures are congruent. Okay, so then the bottom, I want you to switch these two up because it's a little more exciting. So make it say, describe a congruence transformation that maps quadrilateral PQRS to quadrilateral ABCD. So we're going to go from this one over to this one. Okay, so I know that when we rotate counterclockwise, it's got to be a positive rotation. But if we rotate clockwise, it's going to be negative. So we're going to come up with the two possible answers for this. And in my opinion, the easiest way to do this is we're rotating around the origin. So I'm going to put a dot there. That's my center of translation. Center of rotation, sorry. And P is the first point listed on the first quadrilateral, and A is the first point on the second quadrilateral. So those are corresponding. So I'm going to draw a segment from my center of rotation to each of those points. So I drew a line to P, and now I'm going to draw a segment to A. Okay, and so you look at these pink lines, and it actually makes an angle, and the angle that you see is your angle of rotation. Okay, so we're going to go from P to A, and it looks like the obvious way to draw the angle in here would be this way, because the ray that goes to P rotates to the ray that goes to A. So that arrow kind of shows the rotation. But you'll also see that that arrow is pointing in a clockwise direction. So that means it represents a negative rotation. Okay? Now I don't make you guys do any really crazy rotations. Everything I make you do is a multiple of 90. So looking at this is a 90-degree angle. Okay, so it's a clockwise rotation, so it's negative. So you can say this is a rotation by negative 90. That is a correct answer. The other option is to start over here at the ray for P and go counterclockwise. So if I rotate this way, that's counterclockwise. That is a positive rotation. Okay, so I know that each of these rotations, if you add them up, that would give you a whole circle. So to figure out how big this purple rotation is, you could do 360 minus 90, because this one over here was 90. And 360 minus 90 is 270. So it's a rotation by 270 degrees. Okay, the cool thing is both of those are correct. Both correct. They both mean the same thing. It's just rotating in a different direction, but you end up with the same end result for either one. I would say that this rotation by 270 is more correct because we like positive angles more than negative angles, but I would not mark off if you had negative 90 on your quiz or assessment.